Modern medical labs are filled with automation. Robotic systems that are worth millions of dollars are running blood samples and moving these samples and processing diagnostics at an incredible speed. But every night, all this comes to a stop. And that begs the question, why do fully automated labs still depend on humans? In other words, when a lab is 90% automated, why is the human holding the medical lab back? And to dig deep into this question, we will take an example. And this is Anand Diagnostics Lab. So this is a place or a medical lab where blood samples from across the country pile up to be tested, and they go through these very complicated robotic systems, and at the end some human being has to remove these test tubes from the robotic system, scan the barcode and store it in a fridge. Now technically, if we just take the robotic system, it should be able to run 24/7, right? And especially in times where, in weekends where the blood samples just pile up, because in the weekends humans are free and they go to get tested, right? So every weekend an insane amount of blood samples rush in, and they pile up in the input fridge where they are stored. But technically, because the robot systems can run 24/7, this should not be an issue. So the problem is not in the robotic systems, it's actually in the humans who take care of the entire robotic lab. And to be specific, it's not the person who takes care of the lab, but it's the person who removes the test tubes from the robotic system, scans the QR code and stores this in a fridge. So this is actually not a made up story or a made up problem. A real medical lab in Bangalore actually approached us with this exact problem. Well, not exactly the same problem. They initially wanted us to build a robot that could pick up test tubes, scan them and segregate them based on those scanned values, right? Well, we did build that. It was very simple, actually. It was all hard-coded. But during the process of building the robot itself, we realized a very important problem. You see, we were not eliminating the legacy workflows. We were just automating one small part of them, right? I mean, think about it. Even if you automate scanning and segregation, there are still people moving tubes, between fridges and centrifuges and racks and diagnostic machines and whatnot. Every manual handoff becomes another bottleneck. And, that changed how we genuinely thought about the problem statement, right? Instead of building a hard-coded robot for every workflow, we asked, what if we could build a general system that could adapt to any lab, any environment, and, we started looking into general policy. But what kind of a robot could actually adapt to any lab and, interact with existing legacy systems? At first, after a lot of thinking, we tried solving this problem with purely software, because I am a software developer and I couldn't think of a better way. So we tried creating an app, right, that could run on any robot or it was a generic robot software layer that could run on different robots. But eventually I realized this fundamentally is a hardware plus software problem, right? You can't just add more software and solve the issue. So that's when I discovered physical intelligence, right? This company, or this group of people, revolutionized the robotic scene, right? And they did this by using something called a vision language action model, right? Or VLA for short. A VLA system can actually perform very general tasks, right? From using natural language instructions, almost very similar to LLMs. If you tell a robot to pick up a guitar, the VLM just understands what resembles a guitar, the closest, and acts accordingly. So that insight led us to gantry systems, right? So, because we needed a very cheap and scalable robot that, you know, that could run like general policy software, because the general policy basically comes from the software, but the robot that uses this has to be incredibly like cheap and scalable, right? So yeah, gantry systems are very like inexpensive, scalable and efficient, and they are way more efficient than robotic arms because they have lesser joints, and combined with a VLA, trained on basic manipulation tasks, a gantry could perform flexible real world operations without being hard coded for every workflow, right? So our vision is very simple: a low cost, intelligent robotic system that can adapt to different labs and automate repetitive operational bottlenecks through natural interaction, right? Our teams, well, we had a lot of setbacks. We lost access to our gantry system, and that's actually a primary reason of why we tried to solve this issue with software. But then, yeah, after realizing we do need a robot that could pull off this general policy problem, our team stayed committed through all these setbacks. And because this problem is actually bigger than robotics, right? Even a small improvement in the turnaround time in a medical lab could end up saving millions of lives down like 5 years. And that's exactly why we chose this problem, right? This could end up saving lives, and it's a value that companies are looking for but don't exactly get. There are a few companies that are trying to solve problems like this, because a VLA based robot could be deployed anywhere, in your house, in industries, and in farms. But the place that needs it the most, it doesn't really have the distribution to get these robots, right? And so this is a very motivating problem for me and my team to solve. Of course, a lot of the people in my team ended up leaving after losing the access to a robot. But I believe with enough grit, we can stay, and we can end up building a system that could solve all these problems.